Hi, I'm Kyle Irvin, an instructional systems designer at Appian, and today I want to talk to you a little bit about interface performance tuning. In this video, we'll go over some tips and tricks to get your interfaces loading more quickly and behaving better for your users. Let's jump in. We'll start with this interface here. This interface was created by Acme Power for use in a portal where customers can view power outage information. It consists of 3 tabs, which users can navigate using these buttons. The first tab allows users to search for outage information at a given address and view details for any outages. The second tab shows a grid view of all outage information in the system. And the third tab shows a chart that displays the number of affected customers over time. So that's how our interface looks. Let's jump into expression mode and see how it's set up. So here in the interface expression, I can see a button array layout with 1, 2, 3 buttons, and below that a choose function with 1, 2, 3 sections. So the way this interface works is that when the user clicks one of these buttons, it adjusts the value of this local variable, active tab, and based on the value of that variable, the choose function will display one of these 3 sections. You can see up top, we have some other local variables as well, grid data, chart data, and outages at address, that are defined using expression rules and integrations that fetch all of the data we need for our interface. So now let's jump to performance view. Here we can see evaluation metrics for our interface expression. The total evaluation time is listed here, and you can see that it is only 29 milliseconds. Now, that seems rather fast. You might have noticed as I was clicking through the interface earlier that it's a little bit slow. So why are we seeing such a quick evaluation time? The reason is that in its life cycle, an interface will be evaluated multiple times. There is always an initial evaluation when the interface is first loaded, but depending on how the user interacts with it, say by clicking buttons, changing tabs, entering information into fields, it will trigger re-evaluations of the interface. And performance view only ever shows you information for the most recent evaluation. If we want to see the performance metrics for the initial evaluation, we'll need to re-initialize our interface by clicking the test button. Having done so, we can see that our initial evaluation time for our interface is around 3.3 seconds, so it's significantly slower. Below that is listed the parameters and direct children. This section shows initially the top level interface components and parameters that get evaluated as part of our expression. You can always drill down by clicking, for instance, down into this choose function in the section layout. If you want to get back up to the top, there are breadcrumbs available up here to get back to the top of the expression. And what this shows us is the evaluation time of a given component, as well as the percentage of the total time. One thing you will notice here is that these percentages often add up to more than 100%. The reason for that is Appian has the ability to evaluate multiple things in parallel, so that although chart data took 3.3 seconds and grid data took 2.4, this happened at the same time, so that the total evaluation time is less than the sum of these evaluation times listed here. Below the parameters and direct children section is a section for descendant functions and query rules. So here we can see all of the children and grandchildren of those listed above. We can see how often they are called, how long they took to evaluate, and the percentage of the total time. And down below that is a section for descendant rules. So this will show the performance metrics for any expression rules that we call or any nested interfaces. So back up top, we can see we have a couple of heavy hitters here that are really impacting our interface performance, namely these local variables, grid data, chart data, and outages at address. We'll address those in just a moment, but before we do, I want to look into this choose function. If I click it to view its children, I can see only a single section layout, despite the fact that my interface expression has 3 section layouts here. Because choose limits the display to just this first section layout, or whatever section layout is specified by this local variable, only the specified section layout gets displayed on screen, and only that section layout gets evaluated at all. The other two section layouts that are not displayed are not evaluated. That makes choose and other functions like it, such as match and if, that can conditionally show or hide information from the screen, useful tools in limiting or delaying the evaluation of certain components until needed. We can see one more such tool if we dig into this section layout a little bit. Here in the contents, we can see a side-by-side layout and a columns layout, and these are reflected here in our expression. But in the columns layout, you'll see I've got quite a bit going on, a box layout, an if statement, and some other things. But none of these show up in Performance View. Here in Performance View, all we can see are the performance metrics for the show when parameter. So for this columns layout, the show when parameter currently evaluates to false. And when the show when parameter of a given interface component evaluates to false, none of the other parameters are evaluated. So this is another way to limit, hide, or delay the evaluation of certain components. One last thing to look at is the performance of a reevaluation, which we can trigger by going to preview mode and typing an address, hitting search, and going back to performance view. Let me go back up to the top of the expression. And we can see that our interface now reevaluated in 1.3 seconds, so it's significantly faster. And if we look down here, we can see that grid data and chart data did not evaluate or did not need to reevaluate. Their evaluation time is less than a millisecond. However, outages at address did reevaluate. So why is that? What's the difference? If we look at the definition of our local variables, you can see that grid data and chart data simply call expression rules, but outages at address calls an expression rule that depends on another local variable, local valid address. And this local variable changed when we typed into that search field. So the default behavior for local variables is that when they depend on information that is changed, they will be reevaluated. If they don't depend on information that is changed, they won't be reevaluated. You can control the precise behavior of your local variables by using a bang refresh variable. Okay, so we've looked at how our interface performs. Let's see if we can improve it at all. So I'll hit test to reinitialize the interface. And let's take a look at the parameters and direct children here. The vast majority of time is taken up by this local bang chart data variable. However, if I look at my interface expression, I can tell by this little light bulb icon here that this variable is not even being used at all. So even though this variable is not being used in my interface, it is still affecting my performance. So it's important to keep track of what you might have left over from a previous version of your interface that might still be there, still impacting performance, even if it's no longer necessary. So we can improve our interface performance simply by deleting or commenting out this local variable and retesting. So now you can see we're down to 3.4 or 2.4 seconds. And now our biggest impact is this local bang grid data. Now this information, the data that this local variable contains, is used to populate this grid here. Now this grid is on the second tab of my interface. And I expect that most users, when they encounter this interface, are simply going to stay on the first tab. So there's no reason to cause their experience to be impacted by information that isn't necessary for them. It's only necessary for people who click to the second tab. So we can actually delay the evaluation of this expression rule, get outages, until this button is clicked. And we can do that by moving this local variable into that second section. So if I copy the local variable and paste it here, and delete the one up top, and go back to performance view and hit test one more time, I can see we're now down to 1.3 seconds. So now this local variable, local bang grid data, won't evaluate until the user clicks to that second tab. So the last local variable drastically impacting our performance is outages at address. Now, this expression rule takes the address that's typed into this field and searches for any outages for that address. But right now, it's still taking 1.3 seconds to run, even though no address has been typed in. So we can cause this expression rule to wait to run until it's needed by using an if statement here. So if I wrap this expression rule in an if statement with the condition of is not null or empty for this local variable, I can make it so that this expression rule only runs once an address is typed in, and otherwise it will simply return null. So now if I hit test one more time to reinitialize the interface, you can see that outages at address is now less than a millisecond. So with the changes that we've made, we were able to reduce the initial evaluation time of this interface from around 3.5 seconds down to just 22 milliseconds. And you can learn more about tuning your interfaces and improving their performance in the course Build Performant Interfaces, which is available in Academy Online, and in the Appian documentation. Links to both of these are in the video description. Until next time, happy building!